Does anyone need the link?
I think I've got it. I think, here, let me see. No. Hopefully, yeah, it's obvious what we're doing here. But I'll grab it for completeness.
And so today we're going over how to use QGIS. If you have questions or you want to learn again how to do what we're doing, go to the main page of our course and then find QGIS videos. And I made a few videos describing these topics actually on the data set that you'll be looking at for the first homework. So hopefully you've downloaded now that data set. Did anyone have any problems? Nope.
You said it was the Ridgecrest one, is that right?
Yes. So then you want to open QGIS. So hopefully you downloaded the version, the 3.10, which is the stable version. Questions? Everything's good? Okay, so then you can open your data by going here and looking in the browser. And then you want to navigate to where the data set that we just downloaded, either downloaded to or where you want to keep it. So for example, I have mine in this folder called QGIS demo. And then when I find it, I see it's called ridgecrest.tiff. So it's a geotiff raster file. So we double click it. And then it is, double click it a few times and then it should show the DM. Did that work for everyone? Mm-hmm. So you can see here, this is the range of elevation values in the units of the data set. So lowest elevation is 626 meters, and then the highest elevation is 639 meters. If you move your cursor around the data set, you'll see where it says coordinate, see the X and Y coordinate of where your cursor is. My cat thinks it's a fun game to play. And then if you see scale, it tells you the scale that you're using to look at the data set. So you'll want to pay attention to the scale when you do your mapping. So the first thing we want to do is to make a hillshade of this area. So to do that, you want to go up here to raster. So this is a raster data set. So many of the calculations that we'll do will start with raster. Then analysis, and then hillshade. So you click that and that opens this window here. So we see Ridgecrest, so that's the only data set that we've opened, and it tells you the EPSG, which is the horizontal coordinate system of the data. So we'll leave band 1, we won't change that. The Z factor and scale factor, you would only want to change these if your horizontal and vertical coordinates of your data are in different units. So for example, if you have lat long for horizontal and vertical, or meters for vertical, so you'd want to change these. But for this data set, everything is in meters. So then these two parameters are important. It's azimuth and altitude of light. So when you make a hillshade, you'll want to make generally at least two, but sometimes multiple more hillshades with different azimuth and altitudes of light. So if you know in advance what the orientation of the features are, then it's useful to have one that's looking straight at them and a second that's looking perpendicular. If you don't know in advance, you can either make a few guesses and figure out where the orientations are, or we'll also make a slope shade in the next step, which you can also use to figure out the major orientations of features. So here, many of the features are oriented northwest. So let's be looking perpendicular to that. So we'll look at, say, 225. And we'll keep the altitude of light at 45, but again, you may want to change this to better bring out some features. And then here it says hillshade. The default is to save to a temporary file. So if you don't change this, it'll make a hillshade, which looks pretty. But then when you want to come back to this data set, it won't be automatically saved to your computer. So I typically want to save that to save to file. So you can go here and then let's go back and save it in this folder where we're working. So we can name it Ridgecrest. It's always good to name things in a way that you can remember what they are. So we'll say hillshade 225 and 45. So this will remind us of the orientation that we're using for the light. So we can say save. And one thing I really like about QGIS is it tells you the command that it's using to make the hillshade. And so this command is using this software package called GDAL, and it stands for Geospatial Data Abstraction Library. And this is a very powerful GIS code, especially for working with rasters. And so when we press run, this is the command that the computer will run to make the hillshade. So we press run, and then less than 1 second, here is the hillshade. Are there questions? I can give you a few minutes to get it to run. If you have questions, please say them out loud and don't just put them in the chat.
For the hillshades, I think it was the elevation of the light. Is that in meters as well? Is that like?
It's an angle.
Okay, it's not the 1 to 360, but the one below it that was 45.
Yes. So that's also in angles. So if you're looking 0, then you're on the ground surface looking straight across, and if you're at 90, you're looking down.
And the other one just rotates it around to rotate the actual features, and that one is like up and down.
Yeah. So in here, the light is coming from the southwest.
Yep. Gotcha.
And so you can see how that is illuminating, for example, this little hill.
All right, cool. Thank you.
So it's good when you're first learning to say, make a hillshade coming with the light from the southwest and see how it illuminates both of these fault scarps, and then do another hillshade looking from the north, and one, say, from the northeast or the northwest, and just make sure that you can understand where the light's coming from and how that affects how you see the features. So for time, we're not going to do this today, but if you make a hillshade looking from the northwest, you'll see this landscape in a very different way. So it's definitely important to plot hillshades looking from different angles. Does everyone have this?
Yep, it's good.
Cool. Okay, so now we'll make a slope shade. So this is another product that will highlight many of the features in the topography. And again, we're still working with raster data sets. Then you want to come to analysis and say slope. So you get this window. An input layer, most likely the default is Ridgecrest hillshade. So most likely you do not want to make a slope shade of the hillshade. Probably, or yes, so for this example, we want to make sure that we go back to the original Ridgecrest data set. So this term here is ratio of vertical units to horizontal. Again, if our data set is completely in meters, we can leave that unchanged. Here's slope expressed as percent instead of degrees. So right now, without clicking this, the output will be in degrees, and that's fine. So we can keep that unchecked. And then again, it says slope, save to temporary file. We want to save it to a permanent file. So we'll click, say, save to file, Ridgecrest slope, save. So here is the GDAL command that we can use to make this slope map. So you can press run. This time it took a little bit more than a second, but as you can see, it's pretty fast. So here is the slope map. See that the lowest slope, which is black, is most of the region, which is around 0, and then the steepest slopes are 42 degrees. If we don't like how this looks, you can make a few modifications. So for an example, instead of going from black to white, you can reverse the color scale and instead show from white to black. And then if you press apply, you'll get the update for what that looks like. And then there's actually very few high slope regions. So you can bring down this max value to say 20. Press apply. And you can tinker this to whatever value you prefer. You can leave it at that. So this is now our slope map, and you can see it very nicely highlights the fault that ruptured in this Ridgecrest earthquake, as well as this complexities in the fault geometry. You guys, have you run your slope map?
Yep, it's looking good.
Yeah, it looks really good.
Are there any questions? Everyone's got it? If you don't ask a question.
When would you prefer using a slope map versus a hillshade map?
So I guess I would typically map, well, from a combination of slope shade.
Essentially, you see different things in each type of map. So
yes, you see different things, and I think it's important to make a slope shade and then multiple hillshades and be frequently turning between each of them. And I think in the Seattle assignment, you'll find doing that quite helpful.
Yeah, I can just add 2 points. One is, in a way, the way Chelsea's colored this slope map, it's as if the sun were vertical, because like the flat slopes are bright and the steep slopes are dark. And so it kind of is a unidirectional hillshade. So it doesn't favor any direction. And so sometimes that makes sure you don't miss stuff, because the hillshade by definition is illuminated from one direction. The second point is remember, slope is kind of a key driver of surface processes. So in a way, this is a more direct index of sort of where the action is potentially.
Yes. I agree with Ramon. But again, even though this is sort of, right, is from multi-directions, don't only look at a slope shade.
One small thing, Chelsea, maybe just for the demo, maximize the window size there for you on your screen. Yeah, that just uses the space better. There you go.